All right, this is Coach Williams, and we are going to look at 6.2 notes today. This should not be a very long video, but it is going to be a very informative video regarding the radical. And the radical is somewhat misconceived sometimes, the perception of a radical. We see this sign. I'm going to go ahead and jump to that part of this. We see the radical symbol and we immediately say, oh, that's the square root. When you see this on the calculator, you'll notice it is right there on the square root button, on the x squared button, and the inverse of a x squared is the square root. So we kind of just naturally assume that without any numbers there, that is a square root of some value. So if we don't specify a value here, then we just naturally assume this is a square root. But this sign is actually a radical symbol. And with this radical symbol, we can actually go to many different roots, and we can assign many different roots. And we will call this nth root of a, we'll do it like this right here. A is our value that we're going to try to factor down, and we're going to factor it down into 3 or 4 or 2 of the same numbers, we'll say. And that number, the nth root, the n, is what we put outside here. That n is also the index of the radical. So if I were to draw a larger version of this right here, okay, a is my end value there. N is my index of the radical. This is actually my radical symbol. That's my radical symbol. And if we were doing an example of this, if you did have the square root of 4, we'll say, the square root of 4 just means what number times itself. We're going to multiply it times itself, so that's 2 times that we use that number. Multiply times itself will give me 4. And we know that is pretty easily 2 times 2. Now, this brings up an interesting point, too, as we get down to some of our core concepts. Because this number is positive, and we have an even index for our radical, we also could say that, hold on a second here, we could say this is the square root of 2 times 2, which equals 2. So, square root of 4 is positive 2. But if you think about it, you could also say this is also a negative 2 times a negative 2. Doesn't that also equal a positive 4? And it does, and so that's the case. The square root of a negative 2 times negative 2 is just negative 2. So we would actually write this right here. Square root of 4, we could write that as a positive or negative 2. Anytime this value in here is positive and this number here is an even number, meaning it can be divided by 2, we know that 2 negatives make a positive. And so this answer will have a negative value and a positive value both. So we'll have 2 roots there basically. But this is our radical symbol. And we can have a 2 here, we can have a 3 there, we can have 15 there if we want to. And we can find out, the value there if we take that root of whatever's inside the radical itself. Again, this is the radical, so we're taking the nth root of whatever value is under the radical. All right, now, when we're talking about radicals, in comparison or in contrast, actually, to powers, something I like to do here, kind of explain this a little bit. Okay, your powers are moving forward by multiplication. Okay, they're moving forward by multiplication. Let's say we have 2 cubed. Well, that's the same thing as 2 times 2 times 2, which we know to be 8. So powers are expanding or increasing it by multiplication, taking the actual base, value of 2, multiplying times itself 3 times. That's what powers do. Okay, radicals or roots, when we're finding roots, you're actually going backwards. Okay, you're going backwards by division. So if you think about it, powers are just the inverse of radicals, or radicals are just the inverse of powers, right? I mean, if we're multiplying to do powers, then we're dividing to do radicals. If you think about it, if we're trying to find, in this case, watch this, 2 cubed is 8. Well, 8 raised to the power, now think about this, we just talked about it, we're inverting, or we're going backwards. Okay, so if I'm taking the cubed root of 8, or, watch this, this is going to be important as we find in our core concepts down below and as we move on to using the calculator in a few minutes here. If we invert the power, the cubed root of 8 is written just like this. We're actually going backwards. So we're dividing. What times itself, 3 times basically, is going to equal 8. So we've got to divide by something and then divide by the same something to get to that something. And in this case, we obviously know this is the same thing as the cubed root of 8. Right? We're trying to find the cubed root of 8. And we know that the cubed root of 8 is 2. Okay? So 2 cubed is equal to 8. Well, we're raising the power of 2, or raising 2 to the power of 3. And so that's 2 times 2 times 2. That gets us to 8. If we want to go backwards, if we want to take the radical or the roots, we're going to get the third root of 8, the cubed root of 8. Well, now we're dividing by 2, dividing by 2, dividing by 2, and that gives us 2. So powers and radicals are just going in opposite directions, basically. And this is going to be key and important to remember in the next few steps here as we move on to the calculator. And mentioning that now, most everything we're going to do with radicals is going to be in the calculator. We're not going to do much of this by hand right now. So, let's move on to some of the core concepts to remember and rules that we have here as we move into solving for roots. So, real nth roots of a. Let n be an integer greater than 1. Okay, so you can't find like a negative root, negative something root of something at this point. We're dealing with integers greater than 1 for n. And let a be a real number, not some imaginary made up number that we can't actually find roots to. This is going to be a real number. We'll talk about imaginary numbers briefly in a second. But we're only going to deal with real numbers. If n is odd, so in other words, if we have an odd number for n, like 3 or 5 or 7, if n is odd, then a has 1. Okay, look at this. If it's odd, it has 1 real nth root. So a to the nth root, or the nth root of a here, is going to be equal to, and we showed you how to write it here. This is another example of that right there. It's the same thing as a to 1 over n. Okay, and we'll get some practice on that in just a minute. If n is even, okay, so we talked about odds. So now if n is even and a is bigger than 0, can't be negative. It has to be positive. So that means that's what this means. A is positive. Then a has 2 real roots, and we kind of addressed that at the top here when we talked about this right here. N is even, a is greater than 0. There's 2 possible values because a positive would get you to the positive, and 2 negatives would also get you to that positive. So there's 2 different roots. There's a positive 2 or a negative 2. All right, and so that's what this is saying here. There are 2 real roots, or nth roots, when n is even and a is greater than 0. All right, so we have a plus or minus a to the 1 over n. If n is even and a equals 0, then a has 1 real nth root, and that's just 0. And then if n is even and a is less than, this is important, if it's even and it's less than 0, then there are no real roots. So if we have a negative number and we have an even n or index, the index is even. So think about this. If I said the square root of a negative 4, can anything multiplied by itself get to a negative 4? You would think, well, oh, it's negative 2, coach. No. Negative 2 times negative 2 is a positive 4. And two positives are going to equal a positive. So I can't get to a negative number with an even index for the radical. I can't get there because if it's even, it means there's two of them. Maybe several times there's two of them, but anytime I multiply a negative times a negative, I get a positive. So there'll be no real roots, and we'll see some examples of that in just a minute. All right, rational exponents. This is just kind of some rules of how you can break these apart or put them back together. Okay, let a raised to the 1 over nth power be an nth root of a, and let m be a positive integer. If I have a to the m over n, well, it's the same thing as a to 1 over n, or the nth root of a, times, or raised to the power of m. And you could rewrite it like this here. The nth root of a raised to the power of m, in parentheses. We'll talk about this again in the calculator, making sure you know how to do the parentheses. And if we put numbers involved in here, 27 to the 2/3 power is the same thing as 27 to the 1/3 power raised to the 2nd power. And we talked about this, the powers of a powers, in 6.1. And so we know that we can do that. We can break that apart because the 2 would just be multiplied times the 1/3, which gives us the 2/3. So we can factor that back out. And that just says we can take this now and make that a radical and raise the whole radical to the 2nd power. Okay, so that's a brief explanation there of radicals. Again, a lot of this is going to be done on the calculator, so there's not going to be a big need for breaking these numbers down and factoring them out just yet. All right, so find the indicated real nth roots of a. All right, so if we're going to be doing these here, we're going to rewrite these first. This tells me, remember that we're going with the format of the nth root of a. Okay, that's what we're going to use, that format. So if we're using that format, how am I going to write number 1? What is number 1 asking us to do? It's asking us to find the square root of 64. Correct? Isn't that what it's asking us? We've got the index of 2, and we've got a is equal to 64. We're trying to find the square root of 64. Okay? That's the same thing as 64 raised to the 1/2, right? You just put 1 over the n. Those are the same thing. And if I'm going to put that in the calculator, watch this. If I'm going to put that in the calculator, I'm going to do 64, and I'm going to use this symbol right here, and I'm going to draw it out on the paper first. But the symbol in your calculator that we're going to use is this rooftop symbol. And the rooftop, or the hat, whatever you want to call it, symbol, we're going to push that button, so that gives us this exponent position now, and then we're going to put in the fraction 1 over 2. So we just say 1 divided by 2. So then we'll put in our fraction 1 over n, basically, in the calculator. So when we're putting this in the calculator, we put in a, and then we press this button, we put 1 over the n value. So 64 raised to the 1/2, or the square root of 64, is 8. Does everybody agree? It does equal 8, but we have a little bit of a problem. This is an even number, n, the index is even. A is greater than 0, so I definitely have a positive 8 that can reach 64, but doesn't negative 8 also give me a positive 64 when I square it? Yes. And so I've got to remember that little rule that says if this is even and that's bigger than 0, then that can be positive or negative. So my answer on number 1 is actually positive or negative 8. Okay? On to number 2. How am I going to write this down? This is going to be the cubed root of 27. If I'm writing that with a in powers form, that's the same thing as 27 raised to what? 1 over n. So what is it going to be? 1 over 3. And like I said, we can put that right in the calculator. 27, use the little rooftop symbol right there. It's going to give me the powers position on the calculator. I'm going to take and put in 1 divided by 3, hit enter, and I get 3. Now, this is an odd number, and that's positive. We don't have to worry about positive or negatives right now, do I? As long as this is odd, I don't really have to worry about positive or negative answers. All right, what about number 3? Number 3, I'm going to have the 4th root of 256, which is also the same thing as writing 256 raised to 1 over n, so it's 1 over 4. Okay, I put that in the calculator. 256 raised to 1 divided by 4, and I get 4. But listen, that's even, and that's positive. So that's greater than 0, right? So I'm going to have a plus or a minus 4 for the answer on number 3, because a negative 4 times would give me a positive answer. A positive 4 times would give me a positive answer. All right, so let's move on to number 4. Number 4, we'll move a little faster now. We've got a root, the index is 5, and I'm going to take the 5th root of 243, right? So I'm going to go the 5th root of 243. Well, 243, I could rewrite it like this, to the 1/5 power. If I put that in my calculator, it's going to give me a positive 3. Again, this is positive. That's an odd number. I don't have to worry about it because that's odd, right? That's a 5. If it had been even, then I'd have to do a plus or minus, but 3 is my answer on number 4. Okay? On number 5, I have the 8th root of 256. Same thing as 256 raised to 1 over 8. Whenever I put that in the calculator, it's going to be 2. But again, I have an even index, and my 256 is greater than 0. So this is a plus or minus 2. It's kind of interesting to note, too, we have 256 here. The 4th root is 4, and the 8th root is 2. Interesting to note here, if you can see the relationship, 4 is twice as much as 2, so it takes half as much to get to 256. Right? 2 is half as much as 4 as far as the roots go, so it takes twice as much as this does to get to 256. Instead of 4, I've got to go 8 times. So it's kind of interesting to kind of see the relationship there as well. All right, number 6, we're going to have the 4th root of 10,000, which is the same thing as 10,000 raised to the 1/4 power, and that's also going to equal a plus or minus because we have an even number index greater than 0 for my A. I left off a 0 there. And then that's going to be equal to a plus or minus 10. Okay? All right, that should be your answers for 4, 5, and 6. Or actually 1 through 6. Let's move on to number 7. Evaluate the expression. So now we're going to put these in the calculator and see what we can find. I'm going to do a little bit of rewriting just so we can kind of understand, make sure we're putting this in the calculator correctly. This is the same thing as 625 raised to the 1/4. So if I put that in, 625 raised to 1 divided by 4, I'm going to get 5. Again, this is an even index, so that's going to be plus or minus 5. Okay? All right, the next one, I have the cubed root of negative 512. So that's negative 512. Now watch how I write this down. This is important as you put this into the calculator. Okay? The question was asked about number 7. We're looking at the index. The index is 4, which is an even number. Okay, and the index tells us that this could be a plus or a minus. Okay, so that question was asked just a second ago. Here I've got a negative 512. Notice how we're going to put this in the calculator. We've got to put negative 512 in parentheses raised to the 1/3 power. For this to come out correctly, well, it still would probably come out correctly, but we want to make sure that we do this for future reference too. But we're going to have, in parentheses, negative 512. We're going to raise that to the 1/3 power, 1 divided by 3. Okay? And you're going to get negative 8. When you're dealing with powers, just as a general rule of thumb, if you're dealing with powers and you have negative numbers, just put that number in parentheses before you raise it to the power, and that'll keep you from making a sign error in the future. Okay? So just keep that in mind whenever you're putting in negative A's, we'll call them. Okay, so this comes out to be a negative 8 on number 8. On number 9, this is the same thing as negative 216. Again, in parentheses, raised to the 1/3 power. If I put that in the calculator, I get a negative 6. Okay, let's move on to number 10. Number 10, I'm going to have the negative 243 raised to the 1/5 power. Negative 243 raised to the 1/5 power. If I put that in my calculator, it should give me a negative 3. Okay. Number 11. Number 11. I have an even index, right? My index, my n value is 6. Because it's even, I'm going to have a plus or minus. Remember that, right? So I'm going to have 729 raised to the 1/6 power is actually going to be a plus or minus 3. Let me just rewrite that, because this is already in the form that we've been writing them in. So this is going to be a plus or minus 3. If you put in 729 raised to the 1/6 power in your calculator, you get 3. But because the index is even, it's going to be plus or minus 3. And then again on this one, we have an even index. And we have a negative A. Our A value is negative. Because it's negative and because the index is even, this is going to have no real root. Can I multiply any two numbers together or any number times itself and get a negative number? The answer is no. You can't multiply and get a negative number if you're multiplying the same number times itself. If I multiply a negative times a negative, I get a positive. Multiply positive times positive, I get a positive. So this doesn't work. There is this thing called an imaginary number. It's I, little I, and it is the square root of negative 1. So you could write this in imaginary form, but right now we're just dealing with real numbers, and imaginary numbers are for whenever you get older, and you can understand that there's no such thing as certain individual fairy tales that we have that I'll not mention in case some of you still believe in them. Okay. All right, so on to number 13. Number 13, rewrite the expression in rational exponent form. So we don't necessarily have to solve these. We're just going to rewrite them. Okay? So in this first one, if we're rewriting this, we know this is the same thing as 4 to the 1/5 power, because we know that the radical is 1 over n, right? The radical form here, the n is 5. So you can rewrite that as 4 to the 1/5 raised to the 3rd power. And then we've got our power of a power rule here. So I can just multiply 1/5 times 3. And so this would give me 4 raised to the 3/5 power. Does everybody see that? Now, again, this one is a odd number, and so we don't have to worry about plus or minus for our answers here. On to 14, we've got -8 in parentheses, -8 raised to the 1/3 power, and then we're taking that whole thing raised to the 2nd power. Okay? So, this is again an odd number, so we don't have to worry about 2 roots. We just have 1. So if I take this -8 to the 1/3 times the 2 out here, I'm going to end up with -8 to the 2/3 power. -8 in parentheses to the 2/3 power. All right, number 15, we're going to have an even. So our answer is going to end up having to be a plus and minus, we'll say. But this is plus or minus 15 to the 1/4 power. And we're raising that to the 7th power. Okay? So we're raising that to the 7th power right there. And that's a power of a power rule again. So this would result in plus or minus 15 raised to the 7/4 power. Does everybody kind of get an idea of what's going on here? All right, let's move on to the next part. In the next part, they want us to rewrite the expression in radical form. The radical form just means we're putting the little squiggly divided by looking sign, right? Okay, so in number 16, we have -3 to the 2/5. So let's break that apart. -3 to the 2/5 is the same thing as -3 in parentheses raised to the 1/5 power, right? And that whole thing raised to the 2nd power. Well, we know that this right here is the same thing as the 5th root of -3. So it's just the 5th root of -3, and then we're going to take the square of that whole thing. So we're basically just going backwards from number 13, 14, and 15. From this form we went to here. Now we're going from here back to the radical form. Yes? Okay, so the questions ask about the 5. What happens to the 5? Well, what happened here is we broke this apart. We used the power rule to say this is the same thing as 2 over 1 times 1 over 5. And so we pulled the 1/5 out of it, because that's my radical. The 1 over 5 is the radical portion of this expression. Okay, so I take the 1 over 5, the -3 raised to the 1 over 5. That whole thing's raised to the 2. If I were to multiply this back together, that would still be a 2 over 5. Well, the 5th root, 1 over n, the 5th root of -3 could also be written in radical form like this. The 5th root of -3. We still have to square all of that, so we still have our 5 and we still have our 2. We just have rearranged the look of this by using the radical itself. All right, so on number 17, we've got 6 to the 3/2. All right, 6 to the 3/2 means that we're going to take 6 to the 1/2. And then we're going to take that whole thing cubed. Okay, because the 3 we're going to pull out. And then 6 to the 1/2 just means that we're taking this square root of 6 and then we're cubing it. Okay, so that is my final answer. I didn't square this off so that you know this is the final answer here. Okay, on to number 18. You're going to have 12 to the 1/4 raised to the 3rd power, right? We're pulling the 3rd power out, keeping the 1/4 so that we can find what our radical is going to be. This is going to be the 4th root of 12 raised to the 3rd power. And that is my final answer on number 18. Okay, so again, we're just breaking that fraction apart so that we can get our radical form of 1 over n, and then 1 over n helps us change it back to this radical form here. Okay, number 19 through 24, we're going to work these as well. And it just says it wants us to evaluate this expression, right? So we're going to take this, and again, we can put this in the calculator a couple different ways, and I'm going to show you one way first. We're going to take this and break this apart for a minute. We're going to say it's 32 to the 1/5, and then we're going to square it, right? You can actually put that right in the calculator if you want to. Just remember that you've got to maintain your parentheses in the syntax here. You're going to have to put a parentheses, 32 raised to the power of 1 divided by 5. And before you put your parentheses, you need to arrow out of that exponent. So you need to arrow over, and then you can close the parentheses, and you can raise that to the power of 2. And that's going to give you an answer of 4. Okay? And that's a lot of work. You say, Coach, man, how am I going to remember all those steps there? I like for you to be able to remember this, but I will show you an easier way to do it. We can put 32 to the 2/5 straight into the calculator, and it'll solve it for us without having to worry about parentheses. So if I put in 32, put the little rooftop symbol here, raise it to 2 divided by 5, I get the same answer. So we can put it in the calculator just like that, and our answer here is going to be 4. Now, it's raised to the 5th root. That's an odd number, so we don't have to worry about plus or minus. 4 is the answer. Okay, we've got negative 64 to the 3/2. Now watch this. I'm going to try to put this in the calculator and see what happens. You should already know what's going to happen before we get started, but if I put negative 64 in, you've got to use the parentheses. Watch what happens when I don't use the parentheses. If I put in negative 64 raised to the 3 divided by 2, oh, I get negative 512. That must be my answer, Coach. No, it's not. You have to use parentheses when you're dealing with negative numbers and exponents, because what it's taking is this. It's saying, I'm going to put a negative sign in front of 64 to the 3/2. So 64 to the 3/2 is 512, and I'm going to put a negative sign in front of that. But negative 64 raised to 3 divided by 2 is actually no real root. It's an error. It can't do that. Why can't it do that, you ask? Good question. Glad you asked. Okay, this is even. This is negative. If this is even and that's negative, I can't take the square root of a negative number, because any two numbers multiplied times themselves will be, or a number multiplied times itself will always be positive, even if it's negative to start out with. So this is going to be no real root. And hopefully I showed you the importance of using the parentheses when you have negative numbers. On to number 21. We're going to have 343 raised to 2/3. 343 raised to 2 divided by 3. And you should get 49. All right. Number 22. 256 raised to 7/8. We put that in the calculator. We get 128. Negative 729 raised to the 6th power. Raised to the 5/6 power. Again, we've got an even index for a radical. And again, we have a negative. So this is going to have no real root. No real root, because I can't get to a negative number with an even index. Okay? Negative 625 raised to the 3/4. Again, this is an even number. Now this one we could argue that you could have the negative of 729 to the 5/6, but I'm going to go with the same hard fast rule here for now, that that's a negative 729, and so because it's even and that's negative, again we're going to have no real root. Okay? And we may come back and argue this later, but for now just stick with the fact that we're taking that as a negative 729, and we're taking the 5/6 root of that. Okay, that is all of the notes for 6.1 or 6.2, and hopefully this has helped you guys and give you a good head start on the practices. We will work on the practice in class tomorrow, and our quiz will be on Thursday for 6.1 and 6.2. Our homework check will be on Thursday. All right, have a great day.